This section is about functions for working with text and words and sentences and other things that are made up of strings. A string is just a sequence of characters. In the Wolfram language, a string can be entered by giving a sequence of characters like this one enclosed in double quote marks. Treating that input as a computation just returns the string unchanged, except that the double quote marks are not normally shown when a string is displayed. The input form function can be used to show the double quote marks. Many of the basic functions for working with strings are similar to functions for working with lists. For example, just as there is a length function for giving the number of things in a list, there is a string length function for giving the number of characters in a string. And just like the reverse function for lists, there is a string reverse function that reverses the order of the characters in a string. There are also functions that are specific to strings. For example, this shows the toUpperCase function, which makes all of the letters in a string into uppercase letters. There's a function called stringTake for strings that works like the take function for lists. For example, this takes the first 10 characters in a string. The string length function shows that the result is a string of length 10. There's also a string join function for joining strings. Many of these functions also work for lists of strings. For example, this shows the stringTake function taking the first 2 characters from each element in a list of strings. The string join function also works for lists of strings. For example, this joins all of the strings in a list into one string. The characters function turns a string into a list of the characters in that string. Applying input form to that result displays the double quote marks, which shows that the result is a list of strings with one character in each string. General functions for working with lists also work for lists of strings. For example, the sort function can be used to sort that list of characters. The invisible characters at the start of that list are space characters, which can be seen by using input form to display the double quote marks. So far, all of the functions in this section have operated on strings as generic sequences of characters, but there's another category of functions that works on the words and sentences and punctuation in a string. For example, the textWords function takes a string of characters and returns a list of the words in the string. And there is a textSentences function that separates a string of characters into a list of sentences. There are many ways to get text into the Wolfram language. For example, this input uses the Wikipedia data function and stringTake to get the first 100 characters in the Wikipedia article on computers. One convenient way to get a sense of what's in a piece of text like this is to create a word cloud, which can be done using the word cloud function. For example, this creates a word cloud for the words in the Wikipedia article on computers. A word cloud uses larger letters for words that occur more frequently in a list, so in this result the words computer and computers are the largest words because those are the 2 most common words in this article. The most common words in this article are actually the and of, but word cloud automatically omits uninteresting words like the, of, and to. Another source of text is the word list function, which gives a list of words from a dictionary. For example, this gives the first 20 words from the output of the word list function. This input uses stringTake to take the first letter of each word in the result from word list and then makes a word cloud from those letters. Strings can contain things other than English words, of course. For example, this uses the Roman numeral function to give a string containing the Roman numeral for 1988. Input form displays the double quote marks to show that the result is a string. This gives a table of Roman numerals for numbers up to 20. Strings can also come up in computations. For example, this uses the list_line_plot and string length functions to plot the lengths of Roman numeral strings for numbers up to 100. There's a function called integer name that can give the name of an integer in English. The result is returned as a string. This makes a plot of the lengths of the names of the integers up to 100. There are various other ways to turn letters into numbers and numbers into letters. For example, the alphabet function gives the letters of the alphabet. There's a function called letterNumber that returns the position of that letter in the alphabet, and a function called FromLetterNumber that does the opposite by taking a number and returning the letter at that position in the alphabet. The alphabet function knows about non-English alphabets too. For example, this gives the Russian alphabet. There's a function called transliterate that converts between alphabets. This transliterates the word Wolfram into the Russian alphabet. Most alphabets do not use exactly the same letters, so this transliteration is usually an approximation. The characters in strings can be anything that can be entered on the computer, including, for example, emoji. This input, for example, reverses a string of emoji characters. Most common operating systems provide tools for entering emoji and other characters. For example, on this computer, choosing emoji and symbols under the Edit menu opens a window like this one. Clicking on items in this window can be used to enter those characters as input or into a string. It's also possible to turn strings into images using the rasterize function, which makes raster or bitmap images. For example, here is a string with letters and an emoji at size 100, and this uses the rasterize function to make that string into an image. Those last two outputs look very similar, of course, but the first output is a string while the second output is an image. The image can be manipulated using image processing functions. For example, this uses the edge detect function to find the edges in that image. That's the end of the examples for this section. Here is the programming vocabulary from this section. There are quite a few functions here because there are just lots of things that are commonly done with strings. You can find more information about these and other related Wolfram language functions by selecting Wolfram documentation under the Help menu to bring up the Wolfram Language and System Documentation Center page, clicking on the Core Language Instructor button, and then selecting String Manipulation, which brings up this page, which includes links to most of the functions from this section. There are also lots of exercises from this section involving a variety of operations with strings. As an example, consider exercise 18. Find the maximum string length of any Roman numeral year from 1 to 2020. One way to do that is to start with a table of all of the Roman numerals from 1 to 2020. What is actually needed here is the length of each of those Roman numeral strings, which can be computed using the string length function. Finally, use the max function to get the biggest number in that list. So the longest Roman numeral string up to 2020 has 13 characters.